uh, we want to find the determinant of matrix M. Determinant of matrix M, being a 3 by 3 matrix, will be found by invoking the Laplace expansion formula, whereby we will be expanding the nth and jth row, the nth row and the jth column. Our main focus will be we will be adding, we sum the products obtained by multiplying the elements on any row or even a column by their cofactors. It is very clear that in order to find the matrix of a 3 by 3 by invoking the Laplace expansion formula, we are required to sum the products obtained by multiplying the elements. That is matrix M equals to summation J equals to 1 to n. That is, for example, we can have matrix M equals to A11, we add A12, A12 on the way to A1n, A1n. So, for example, in this case, the matrix of M, in this case, by expanding using the first row, then we will be having 2, this one, we cancel the elements where 2 lies on that row and this column, then we will be having these elements, we'll be having these ones, we're having 2 into 2, -3, then this is 3, then minus, we will be having 4, this is 4, minus 4 into elements where the row where 4 is will not be considered, then where the column where 4 is will not be considered, then we'll be having this one and this one will not be there, then we'll be having this and this and this one, then that is 3, -1, -3 and 3, then plus 1 into this is this row and this one will not be considered, we're having 2, 3, 2, -1 and -3, then we'll be having that is 2 into, let us try to solve, 6 multiplied by 2 multiplied by 3 is 6, -3 by -3 is 9, 6 minus 9 is -3, minus 4 into 3 multiplied by 3 is 9, -1 multiplied by 3 is 3, 9 minus 3 is 6, plus 1 into, then we have 3 multiplied by -3 is -9, minus -1 multiplied by -2 is -2, so it will be -9 minus 2. So we'll be having -6, that is 2 multiplied by -2 minus -24 plus -7, because this one will be a plus, minus, this minus and minus, So actually this will be, this and this is negative 13, this one is negative 37. Determinant m denoted as m equals to negative 37. What if we expand by the second row? By second row, will the answer be the same? Yes, it should be the same. Let's give a proof so that we at least prove that even if we expand using different row or columns, we arrive at the same answer. Then we'll take 3 by second row. This element will be the one which will be in consideration. Then the elements where 3 is, that column and this one not appear. Then we'll be having 4. Then we'll be having 1. Then we'll be having negative 3 and 3. Then this one ought to be a minus. Then why? Because we value the cofactor. Where is 3? 3 is at row 2, column 1. That is 2.1. If we add 2 and 3, we get 2 and 1, we get 3. And negative 1 raised to power 3 in getting that cofactor is negative 1. So it has to be a negative here. Plus, then we'll be having our 2, which will be these elements here will not appear, and this one. Then we'll be having 2, 1, negative 1, and 3. Then we'll be having minus negative 3 into these elements, and this one will disappear. Then we'll be having 4, 2, and 4. Then negative 1 and negative 3. So again, this is negative 3. Let us try to solve. 4 multiplied by 3 is 12. 12 minus negative 3 multiplied by 1 is 1, negative 3. That is 12 minus 3 is 15. It becomes a positive. Plus 2 into 2 multiplied by 3 is 6. 6 negative 1 times 1 is negative 1. 6 minus 1 is 7. Then we'll be having minus. That is 3 into 2 multiplied by negative 3 is negative 6. Negative 6 minus 1 multiplied by negative 4. Negative 1 multiplied by 4 is negative 4. It will be negative 6 minus 4. Then we'll be having negative 45 plus 14. Then negative 3 into this one will be a plus. That is negative 2. Then we'll be having negative 45 plus 14. Then that one will be minus 6. Why? Because remember, this cofactor ought to be a negative here. Then it should be a minus. So a minus is a plus. This one will be a plus. Then we'll be having plus 6. So plus 3, plus 3 into negative 2. Plus 3 into negative 2, which is negative 45 plus 14 minus 6. What is we have to apply the body mass. That's addition first. Then negative 45 plus this one is negative 31. Negative 31 minus 6 is negative 37, which is the same as what that is m. The matrix of m is negative 37, which is the same as what we found on that side. But remember, when you are doing the expansion using the Laplace equation, the cofactors is a mandatory concept or aspect that you have to put into consideration and get to understand. When you are expanding on the first row, the first element will be, if it is a 3 by 3 matrix, it will be negative. It will be a positive, negative, positive. If it is second row will be negative, positive, negative. If it is the third row, remember, it will be third row, it will be positive, negative, positive. If it is fourth row, it will be negative, positive, negative. Why? The cofactors affect the values of those elements at each point of those entries. Now, for example, in this one, we say in our example, it should be here in negative, plus a negative. This one, in consideration to this, because if we had a 2, this is order 2 is at 2, row 2, column 2. 2 is at row 2, 1, 2. This is row 2. Which column? 1, 2, column 2. 2 plus 2 is 2. It doesn't affect. It will be that way. It will be plus, because negative 1 squared, negative 1 raised to power 4 is negative 1. That is when finding the cofactors. And again, when we come to negative 3 here, negative 3, then it's at 1, 2. Negative 3 is at row 2, and then 1, 2, 3. Negative 3 is at column 3. So we'll be adding the elements of row and column. Then we're having 5. Negative 1 placed power 5 is negative 1. That's why we say that value that we'll be having at this point. Then let's say this one, it has to be raised. It has to be multiplied by a negative. Yeah.